Today we're going to start working on hyperbolas, so get ready to take notes. Here we go. So first we're going to talk about the standard form for hyperbolas. There are actually two different standard forms, but you'll notice they're really similar. So you have x minus h squared over a squared minus y minus k squared over b squared equals 1. And then you just have the opposite, the y minus k squared over a squared minus x minus h quantity squared over b squared equals 1. The equations are very similar to ellipses, and a lot of the work is going to be very similar. The one big thing that's important for you to notice is that in ellipses, the a and b switch. In hyperbolas, the a is always under the first one. So a is always under whatever's first. When you have these two standard forms, you're going to get two different graphs. If your x is first, you're going to get a hyperbola that opens in the x directions, so side to side. Then you're going to have asymptotes that cross there in the middle. We'll talk more about those later. When the y is first, then you're going to have a hyperbola that opens in the y direction, which is up and down, vertical. So an x hyperbola looks like this, side to side. Y hyperbola looks like this, up and down. Okay, so let's start doing the math. So example 1. We have the quantity x minus 1 squared over 16 minus the quantity y minus 2 squared over 9 equals 1. So we're going to find the center the exact same way that we did with ellipses. So the way that you do that is you find your x coordinate and your y coordinate, and remember we have to do the opposite again. So our center for this hyperbola is going to be 1, 2. Then we find our a and b, again just like we did with ellipses, except remember the first one is always your a with hyperbolas. So our a is 4, our b is 3. Because remember this is a squared and b squared, so we just have to take the square root of those to find our a and b. Okay, another thing to keep in mind before we go too much further, the x is first here. So that means this is going to be an x hyperbola, which means it's going to go side to side. So when we go to find our vertices, we're going to move this many steps in the x direction. So that means we're going to move 4 spaces away from 1. So when we move to the right, that's going to give us 5. We're not going to move up at all, so our y coordinate is going to stay 2. When we move to the left, so we're going to actually move 4 spaces to the left from 1. So that's going to be at -3, 2. And I'll show you a quick, easy way to find that when I actually go to make the graph, if you don't want to do that in your head. Okay, just like we have foci on an ellipse, we also have foci on a hyperbola. Remember, with an ellipse, you had something that looked almost like the Pythagorean theorem, but it had a minus sign there. Well, with a hyperbola, you have what is exactly looking like the Pythagorean theorem. So that's now a plus sign. So quick, easy way to remember that, they're the opposite signs from the equation. So in an ellipse, you have a plus in your equation, a minus down here. In a hyperbola, it's the exact opposite. Minus up here, plus down here. So to find our c in this case, we have a squared, which is 16, plus b squared, which is 9, equals c squared. Basic Pythagorean theorem from middle school, 25 equals c squared. So c equals 5. Again, because we're doing an x hyperbola, our foci are going to move in the x direction. So we're going to move 5 spaces away from our center. So our foci are going to fall at 6, 2, because we moved 5 spaces to the right, and -4, 2, because we moved 5 spaces to the left. And again, I'll show you a quick way to find that once we do our graph. We're going to hold off on the asymptotes until we do our graph. Okay, so let's talk about graphing this stuff. So we have our graph here. We're going to start off by graphing our center, which again was 1, 2. So over 1, up 2. There's your center. Then remember that our A value was 4. So we said we were going to move 4 spaces in the X direction. So we started our center and go out 4 spaces. 1, 2, 3, 4. And then we go left 4 spaces. 1, 2, 3, 4. So again, if you didn't want to find the vertices by hand back at the beginning, you could find them here and then write them down. So that would be the 5, 2 and the negative 3, 2 that we got to start with. Okay? All right, now, we have a B value of 3. That's not actually going to give us anything in terms of something that we have to write down, but it's going to help us graph these things. So what we're going to do is we're going to take that B that was under our Y, and we're going to go up and down 3 spaces, just like you used to do on ellipses. Okay? Now what we're going to do is we're going to make a rectangle out of these 4 dots. We're not going to make a diamond. We're not just connecting them. We have to go over, down, over, up, over. Okay? Not a diamond, not connecting the dots. We have to stay on the streets here. Okay. Then what you're going to do is you're going to connect the corners of this rectangle with a diagonal dotted line. That's going to be your asymptotes. So you want to extend it out past the rectangle. So it's going to look like there's one asymptote. There's the other asymptote. So you should remember from your rationals unit, an asymptote is a line that your curve approaches but doesn't intersect. So we're just going to draw in our 2 curves for our hyperbola in between the asymptotes. Now this again is where it's important that we have to remember that this is a side-to-side hyperbola because the x came first. So I'm going to use these 2 dots, not these 2. So I'm just going to have one curve that goes like this, and another curve that goes like this. Okay, we have 2 things left to do. We need to plot our foci, which we found that our C value is 5. So again, you're going to go 5 spaces out from your center. And since we're doing an x hyperbola, we go on the x direction. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If your foci aren't inside of these curves, if they're in here somewhere, you've messed up. Your foci should always be in the middle of your curve here. Okay, and again, we had already figured out what those were supposed to be mathematically, but you could also do it graphically by drawing them first and then finding the coordinates of those points. The last thing we have to do is we have to write the equation of our asymptotes. Now I could take you back through the whole thing from Algebra 1 of finding the equation of a line, blah, 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 but we're just going to make this easier on ourselves. So the way that you do this is it's always going to be y minus the y coordinate from your center, so y minus 2 equals plus or minus, leave some space there. We got to go back there in just a second. And then x minus the x coordinate from your center. Okay? Now, here, we should remember from Algebra 1, this is a little bit of torture, that a line always has a slope, unless it's a vertical line, which doesn't have a slope. All right, so we need to find the slope of these asymptotes. So you can either count rise over run, 1, 2, 3, over 1, 2, 3, 4. So up 3 over 4. So our slope is 3/4. And after you do a couple of these, you'll probably notice real quick that those are the same numbers that are up here in A and B. But instead of trying to memorize which one goes on top, which one goes on bottom, you should know how to find slope from Algebra 1 and Algebra 2. Why is it plus minus? Because we have two asymptotes. We have one that's going up this way with a positive 3/4 slope, and we have another one that's going down this way where the slope would be negative 3/4. Okay, let's try another example. So this time we have y minus 3 quantity squared over 4 minus x plus 1 quantity squared over 16 equals 1. So first thing to notice is y is first this time. That means we got to get our brains going. That means we're going to be doing an up and down hyperbola. It also means that people make a lot of dumb mistakes. So you have to be very careful. And the first one is right at the very beginning. When I go to find my center, we know that the x coordinate has to come first. So you have to be careful. People get carried away and just start bringing things down. Our x coordinate has to come first. So -1 comes first, +3 comes second. So again, that's somewhere you have to be really careful that you don't do a dumb thing. All right, but remember again, a always comes first on a hyperbola. So a is 2, because it's the square root of that. B is 4. Again, we can either find our vertices now, or we can find them later when we go to do the graph. So this time I'm going to find them later. All right, foci, again, we use the formula a squared plus b squared equals c squared, because it's the opposite sign of that one. So a squared is 4, b squared is 16, that equals c squared. So c squared equals 20, so c equals the square root of 20. That's not as nice and pretty as some of our other ones, but we'll make it work. Okay, and we're going to save the asymptotes for later. So let's go back through that real quick. We found out that we were doing a y hyperbola because y came first. So we're keeping this in our brain. We're being very careful here that we pull our center from the right places. So the x comes first, y comes second. Our a comes from underneath the first part, b from the second part. And then we use a squared plus b squared equals c squared to find our foci. All right, so let's look at how this would look when we go to graph it. So we start off, we graph our center, -1, 3. So back 1, up 3. The a value of 2, let me rewrite the equation here so we can see what we're doing here. Y minus 3 squared minus x plus 1 squared equals 1 over 16 over 4. Okay, so this a value, which is actually 2 because we have to take the square root of that, that's under the y. So that means we're going to move 2 spaces in the y direction. So that means we're going to go up 2 and down 2. And since we're doing a y hyperbola, those are my vertices. So I'm going to go ahead and write those down. So that's -1, 1. And that's -1, 1, 2, 3, 4, 5. And again, we could have gotten that mathematically, because if this is 4, that means a is 2. I'm going 2 spaces in the y direction. So 2 spaces from 3 is 1 and 5. Okay, remember we're also going to take what's under the x to help us make our rectangle. So we're going to go 4 spaces, 1, 2, 3, 4, 1, 2, 3, 4. And remember, we're not making a diamond, we're making a rectangle. So over, down, over, up, over. Draw in your asymptotes, which are your diagonals of your rectangle. So we're doing a y hyperbola, so this time we draw our curves. Ooh, that was a little too close for comfort. That way. And this way. Okay, so our foci, we need to go radical 20, the square root of 20 spaces away from here. Well, if you think about it, the square root of 16 is 4, the square root of 25 is 5, so this is a little bit more than 4. And if you want to, you can type that in your calculator and you'll get a decimal and you'll see it's a little bit more than 4. So we're going to go a little bit more than 4 spaces away from here. So 1, 2, 3, 4. We're going to put a dot. 1, 2, 3, 4. And we're going to put a dot. And again, like I reminded you on the last one, your foci should always fall in your curves. So that's good. They are where they're supposed to be. How do we write those down? Because that's a little bit ugly. Well, it's not going to make as much sense to you, but it's kind of easy to do. Keep your x-coordinate the same because we're doing a y hyperbola, so x really didn't have anything to do with this. We take our y-coordinate and we put it there, and then we just literally write behind it plus or minus the square root of 20. Because I had to go up the square root of 20 spaces and down the square root of 20 spaces. So these are our foci. There's 2 of them there, right? Because you have a positive and a negative. These are 2 different things. All right, then last but not least, we have to find our asymptotes. So again, y, and then minus 3 equals plus minus. We're going to have to find our slope here in a minute. This would be x minus, but once you do x minus negative 1, like you learned back in middle school, we don't do double signs. So that just becomes an x plus 1. All right, now we need to find our slope. And again, you're just finding from here to the corner of your rectangle. So up 2 over 1, 2, 3, 4. So up 2 over 4. But we're smart cookies, so we know that really that's bad math. We should reduce that to 1/2. And remember, why is the plus minus there? Because we have 2 asymptotes, positive 1 and a negative 1. Okay, I'm going to do one more example. I'm going to take it a little bit quicker since we've been through one of each of these. So hopefully we can get through this rather quickly. Okay, last one. X plus 2 quantity squared over 1 minus y minus 3 quantity squared over 4 equals 1. So first important thing to notice is that this is going to be an x hyperbola, which means our picture should go side to side. Our center is negative 2, positive 3. You guys should be pretty good at that by now. So back 2, up 3. There's our center. Our a value is 1, because the square root of 1 is 1. Our b value is 2, because the square root of 4 is 2. So we're going to go 1 space in the x direction. So over 1, over 1. So those are our vertices, because that's the kind of hyperbola we're doing. So I'm going to do this one by just counting. Negative 1, 3. I'm going to do this one. We went back 1 space from here, so that should be at negative 3, which it is. Negative 3, 3. We do this one just to help us out with our box. So we go up 2, down 2. Draw a rectangle, not a diamond. Draw in your asymptotes. This is going to be a skinny thing. Actually, it's going to be a fat thing because it's going the other way. All right. Again, where we have to figure out where to draw our curves, we're supposed to be doing sideways. So we should be going here and here. Last two things, we need to find our foci. So again, that's a squared plus, oops, my brain got ahead of my hand, b squared equals c squared. C squared equals 5. So c equals the square root of 5. So we're going to add the square root of 5 and subtract the square root of 5. We're doing an x, so we're going to do it to the x coordinate. So this is what it looks like. -2 plus or minus square root of 5, comma 3. Square root of 5, square root of 4 is 2, so this is a little bit more than 2. So we're going a little bit more than 2 spaces in the x direction. So there, 1, 2, a little bit more, and there. We have to find our asymptote equations. And again, that's y minus 3 equals plus minus, we have to find our slope, x plus 2. So our slope up 2 over 1. So our slope is 2 over 1. So really we could just write that as 2, because 2 over 1 is the same as 2. Hope that helps, and you have some homework to do.